Balancing the chemical equation, we have the equation Fe reacts with H2O gives rise to Fe3O4 plus H2. So we have the reactants Fe, it is a ferrous, and H2O, water, and as a product we have Fe3O4 and H2. As we see, the equation is not balanced. So how to check that? So here we have one atom of Fe, but at the product we have Fe3 as a 3 atom. And if you see hydrogen, we have 2 hydrogen atom in the left hand side, and we have in the right hand side 2 hydrogen atom. So that hydrogen atom is balanced. But if you see the oxygen, we have 1 oxygen and we have here 4 oxygen atom. The equation is not balanced, so we need to balance this equation. So let us go step by step. Let us start with the step 1. Step 1, to balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. So step 1, draw boxes around each formula. Now let us draw the boxes around each formula. So we need to remember that we should not change anything inside the boxes while balancing the equation. Now step 2, list the number of atoms of different elements present in the unbalanced equation. So step 2, list number of atoms of elements. So in the left hand side we have 1 atom, and in the right hand side we have 3 atoms of Fe element. So the ferrous element has 1 atom in left hand side and 3 atoms in right hand side. Now let us find out for hydrogen element. So as you can see here, there are 2 atoms in the left hand side and there are 2 atoms in the right hand side. So for hydrogen, the number of atoms present in left hand side is equals to the number of atoms present in right hand side. Therefore the hydrogen atom is balanced. So we have hydrogen atom, that is 2 atom in left hand side and 2 atom in right hand side. Now let us find out for the next element, that is we have oxygen. So how many atoms here? We have 1 atom at left hand side, that is at the reactant side, and at product side we have 4 atom of oxygen. So oxygen, we have 1 atom in left hand side and we have 4 atom in right hand side of the equation. So this element is not balanced. Now let us go to step 3. Here it is convenient to start balancing with the compound that contains the maximum number of atoms. It can be a reactant or a product. Also in that compound, select the element which has the maximum number of atoms. So in the equation at the product side we have the compound which has the maximum number of atoms present. Particularly in that oxygen has more number of atoms. So in the compound Fe3O4 we have oxygen has a more number of atoms as an element. So step 3, first select the compound with the maximum number of atoms. So we can consider taking Fe3O4. Also we need to select the element which has maximum number of atoms. So in that we have 4 number of atoms present in an oxygen, present as an oxygen. So we need to balance the oxygen atom now. So let us see how many number of atoms present in the left hand side of the equation. So as you can see here, we have only 1 oxygen atom on the left hand side, but at the right hand side we have maximum, that is 4 number of atoms. So we need to balance this. So how we are going to balance? So to balance the oxygen atoms, so we can put coefficient of 4, coefficient 4 for H2O on the left hand side. So here we have to remember that we cannot alter the formula of the compound or elements involved in the reactions. As an example, here to balance, we cannot put 4 here. You can see here we cannot put 4 here for the oxygen. Also, we cannot put like this. Cannot put 4 like this. That is wrong. That will alter the formula of the compounds. Instead, we can put coefficients as like we have written here. Now after adding the coefficient, we can see that the oxygen atom, that is we have the left hand side we have 4 oxygen atoms, and at the right hand side we have 4 oxygen atoms. So now the oxygen atoms are balanced, but we have other elements which are not balanced. Here oxygen atom is balanced, but Fe and hydrogen atom are still not balanced. So in step 4 we will balance hydrogen and iron atoms. So here in step 4, let us balance hydrogen atoms, and in step 5, let us balance iron atoms. So here as you can see, there are 8 number of hydrogen atom in the left hand side, but in the right hand side we have only 2 number of hydrogen atom, so which is unbalanced. To equalize the number of hydrogen atoms, we make the coefficient of hydrogen as 4 on RHS. So here in RHS we are going to make coefficient as 4. Now the equation becomes like this. Here in this equation you can find that there are 8 number of hydrogen atom in the left hand side. You can see here there are 8 number of hydrogen atom, and in the right hand side also we have 8 number of hydrogen atom. So the hydrogen atoms are balanced. In step 5, let us balance iron atoms. As you can see in the equation, in the left hand side we have 1 iron atom, and in the right hand side we have 3 iron atom. So we are going to make the left hand side iron atom, the coefficient of the left hand side iron atom as 3. That is, we are making the coefficient as 3. So in step 6, finally, to check the correctness of the balanced equation, we count atoms of each element on both the sides of the equation. So in this equation we can see that the ferrous atom, that is the iron atoms, are balanced, and that is 3 uh, iron, iron atoms, and here 8 hydrogen atoms, and 4 oxygen atoms. So coming to the right hand side we have 3 iron atoms and 4 oxygen atoms and 8 hydrogen atoms. Therefore numbers of atoms of elements on both the sides are equal, so therefore this equation is now balanced. This method of balancing chemical equation is called hit and trial method. Now in step 7, writing the symbols of physical states to make a chemical equation more informative. The physical states of the reactants and products are mentioned along with their chemical formula. We represent gaseous state with the symbol small letter G, liquid state small letter L, aqueous state small letter AQ, and solid state small letter S. Here the word aqueous is written if the reactant or product is present as a solution in water. Therefore the balanced equation becomes 3Fe, which is in solid state, plus 4H2O, which is in gaseous state, and Fe3O4, which is in solid state, plus 4H2, which is in gaseous state. Here in the equation, that is 4H2O, which is in gaseous state, is used to indicate that in this reaction water is used in the form of steam. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. For example, CO, that is in gaseous state, carbon monoxide, plus 2H2, which is in gaseous state, and we can also write that is 340 atm, that is which represent 340 atmospheric pressure. The reaction is undergoing in the atmospheric pressure, that is 340 atm. CH3OH, which is in liquid form. So this is an example to show that this reaction is undergoing with the pressure of 340 atm.